All right. So the SAT math skill rather, that I would like to work on today is the skill of exponents. Exponents. Now, these are pretty straightforward, pretty easy. But you just got to make sure you remember the rules so you don't get tripped up. All right, so let's go ahead and lay it out here. So first of all, if you have some number A raised to some power n, then basically that is going to be equal to a times a, so on and so forth until you get to whatever that nth a is. Another way you can write that is like this: n times. It's whatever the base number a is multiplied times itself n times. Okay. All right. So let's keep it going. Um, any number raised to the zero power is equal to one. Anything, anything raised to the zero power is equal to one. Okay. All right. So let's keep it going. You have a number raised to a negative power. That is going to be equal to that same number in the denominator of a fraction raised to a positive n power. Okay. And we're going to practice examples later on that will kind of like combine all of these, but I just want you to just listen and take note of these, and then we'll practice the skills later. All right. So, um, if you have something of some number raised to a fraction of power, 1 over n, this is actually the nth root of a. To clarify that a little bit more, if you have something raised to the m over n, that is equal to the nth root of that power to the m. So you see the top number is what the a is raised to. The bottom number is the index of the root. So it's a lot here, but again, we're going to apply all this in a second. Okay, what next? So if you have some number a raised to the m power, and then all of that is being raised to the n power, that is the same as a to the m times n. If you have a number a raised to the m power times that same number a raised to a different power, that's going to be equal to a to the m plus n. Now, these are easy to get mixed up, so you got to really make sure you distinguish. This is when you have something raised to a power that's raised to a power as well. This is when you have two numbers being multiplied times each other, same base, different exponents. You add them, but you got to have the same base. All right, so if you have um uh a to the m over a to the n, that's going to be equal to a to the m minus n. Okay. If you have some fraction raised to the n power, that's going to be equal to a to the n over b to the n. Also, note this: if you have a over b, some fraction raised to the negative n power, that's going to be equal to b to the n over a to the n. You see how the negative power made the fraction flip essentially, because it's a to the negative n over b to the negative n. So anything to a negative power is going to go from the denominator to numerator or numerator to denominator. Okay, let's see what else we want to put here. Okay, yes, keep on going. So if you have two numbers being multiplied times each other and being raised to a power n, that's going to be equal to each of those separately raised to the n power, of course, still multiplied times each other. Then if you have some fraction raised to the fractional power, that's going to be equal to each of those separately raised to that fraction of power. Sorry, it's supposed to be a b, fraction of power, which is also equal to, as we said earlier, the nth root of each of those. And note that you can also write it like this too. Okay. All right. Good. So now that we have all of that, all those rules kind of taken care of course, I'm dealing with them kind of fast. So you're going to want to pay a little bit more attention to them than I am in this video because I'm just trying to make it concise here. Let's do about 3 examples just to kind of apply this stuff. So I'm gonna just kind of keep these up here for your reference. Let's do some examples. Okay, so if you have the following, we want to simplify -5 to -2 power, and then all of that to the 5th power. Okay, so remembering our rule here that says something to a power raised to a power is equal to those exponents multiplied times each other for that same base, we know that this would be equal to -5 to the -10th power because -2 times 5 is -10. So this is a negative power though. So this is also going to be equal to 1 over -5 to the +10th power. All right, let's do another one. What about 1,000 to the 2/3 power? Now, it'll probably help to, because we know whenever you have a fraction of power, you're dealing with like a root kind of thing. So let's actually rewrite it as, remember, that's going to be the 3rd root of 1,000 squared. So now let's see under here, 1,000 squared is going to be 1,000,000 because that's 6 zeros. So that's going to be the cube root of 1,000,000,000. Now, cube root means it's something multiplied times itself 3 times. So what times what gives us 1,000,000? So we got 1, 2, 3, 4, 5, 6. So that's going to end up being 100 because 100 times 100 is what's that, 10,000? And then 10,000 times another 100 is going to be 1,000,000. All right, the final example that I would like to go over. Let me see which one of these I want to do. Let's do this one right here. If you have 16 x to the 16th power, y to the 8th, and then all that raised to the 1/4 power. So remember, a fractional power means we're taking that 4th root. So what's the 4th root of 16? In other words, what times what times what times what gives us 16 in the same number? That's going to be 2. Now, when you got this number raised to a power and then that's raised to another power, we can multiply these. So 16 times 1/4 is going to be 16 over 4, which is 4. So it's going to be x to the 4th power. And then y to the 8th raised to the 1/4 is going to be 8 over 4 or 2. So y squared. Okay. All right. So very good. So we've done some very quick practice on exponents. If you want more in-depth practice, then we for sure go a little bit deeper, get a little more practice in the class. You see the link to the class that I do every week. So keep that in mind. And otherwise, practice, practice, practice. The key to doing better on SAT math is getting in problems. Do problems. The more problems you do, the more you get used to them. Okay. All right. So hopefully this has been helpful. Share it with a friend, who needs help with the SAT as well.